Welcome back, everyone. I hope you're ready for a new lesson today. On the screen, it says exactly what's going on. We're going to be going over creating quadratic regression models. We're going to be going over this using the calculator, so it'll be a lot of calculator work. I hope your calculator is with you and ready. So that's that. Let's go ahead and begin. So we have our first problem right here. It's just a table. And we could start by plotting points for this. So actually, let me turn my grid on. And we could start by plotting these points. So if I'm looking here, let's see, let's get a nice grid going. So I could put these down. That's that. All right, hopefully that's good. All right, so I got -1, -1. Put a point right there. I have 1 over 1, 2, 3 up. And I have 2 over 1, 2, 3, 4, 5, 6, 7, 8 up. All right, it's up there. Okay, so I kind of see, I kind of have a parabolic shape. I don't exactly know that this is my vertex. And so we kind of want to get something that can go through the line nice and perfectly. I know my parabola is not perfect, but we want it to kind of go through those 3 points as much as possible. So I know my graph kind of sucks, but we are going to be doing it on the calculator where it's going to look a lot better. So go ahead, power up your calculator. Let me pull this off to the side. All right, there we go. And I got my calculator on. So we're going to go over here to the stat function right here in the middle of your calculator. So you're going to hit stat, and you're going to go over here to edit. So number 1, edit. And we're going to put in all those x values that we have. So I'm going to put in -1, 1, and 2. All right, and then over here on the right, we're going to put in all the y values that I have. So I have -1, 3, and 8. All right, so we're going to hit second and quit right here. And we're going to go back to stat so we can use the math functions. And we're going to go here to calculate, and we want to create a quadratic regression model. All right, and so this is right here what we're about to do is going to create a line of best fit. So we're going to hit enter. And so I kind of had the new model. So when it comes up, you're going to usually want to hit like second L1 and second L2, and that'll be good enough. We're not going to do anything with the frequency list, or we're not really even going to store the regression equation. If we need to, we can write it down. But we're just going to hit calculate down here at the bottom, hit enter, and it figures it out for us. All right, so I'm going to pull this off to the side. I got that. Actually, I'm going to go grab my stat 2. Let me see, let me pull that down a little bit, and I have my stat, so everyone can see that. Okay. And so what I have right here, this is giving me my A, B, and C. But if you look right here, I got some funky stuff happening right there. So right there. So I know A is 1, I know B is 2. But right here, I had to think about this. It's saying -8.3. And what does that E mean? Well, that E, let's see my cursor. All right. So -8.3. And all that E means is scientific notation, so it's times 10 to the -13. I don't know why I wrote 0. That should definitely have been a 3. Let's see, get it back there. So -13. Okay, and so we're going to bring this decimal place 13 places to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And you would fill in every one of these with a 0. So I got, all those zeros. And then I have my decimal point over here, 0. So if I'm looking here, I have a really, really small number. And so the calculator is actually struggling to tell you that C is actually equal to 0. We'll just round it off to equal to 0. And so we're going to write out our function now. So y equals, A is 1, so we're going to put in x squared, plus B is 2, so 2x, and C is 3, so we're going to leave it off. And that is my quadratic regression model for this data. X squared plus 2x. So let's go ahead and move on to our next problem. Oh my god, it's a word problem. But it's actually not going to be that bad. Let's read it first. A man throws a ball off the top of a building and records the height of the ball at different times. That's shown in the table. So we have our table off over here to the right. And I guess we're going to be using that because data is in the table. And we're going to, so very first thing it says, find a quadratic model for the data. Okay, well we just went over how to do this. So go ahead and do that on your own. Let's see, we got stat. Oh, I'm already in stat. Edit. Alright, and so I want to put in those values that I have. 0, 1, 2, and 3. And then over here on the right, 46, 63, 48, and 1. Okay. So go back here to stat, calc, quadratic regression, number 5, all the way down to the bottom, and calculate for me, calculator. Alright, I want to go ahead and grab that. There we go. That's a good spot for it. Alright, so we're working on A here. And actually I squeezed my window. Alright, there we go. And we want to create a quadratic model for the data. Well, there it is. That's what we just did. So I'm going to put it down. Y is equal to negative 16x squared plus 33x plus 46. You can see like this kind of makes sense because this 46 is, you remember your C is going to be your y-intercept. And at time 0, when x equals 0, my y is 46. So it kind of makes sense. So we're going to be using this model to estimate the height of the ball at 2.5 seconds. Simple enough. We're just going to put in y equals and 2.5 in for x. Negative 16, 2.5 squared plus 33 times 2.5 plus 46. So we're going to be putting that in. Okay, now let me clear this out. So negative 16 parentheses 2.5 and then squared, and then plus 33 parentheses 2.5. Then what do I have over here? Plus 46, right? Yeah, plus 46. Plus 46. Enter. So at about 2.5 seconds, the height of the ball is about 28.5 feet. So we're going to go ahead and record that. So y equals about, and what was that, 28.5, right? Yeah, 28.5. So 28.5, and don't forget your unit, feet. That's an ugly 2. There we go. That's a little bit better. Alright, so that's part B. We want to know what is the ball's maximum height. There are a couple ways we can do this. We could do negative b over 2a. Find the vertex, find that x value, and then plug it in here like we just did with the 2.5. But since we're doing a lot of work on the calculator today, we're going to keep it calculator simple. We're going to take our quadratic regression model. We're going to plot it. So it was negative 16x squared plus 33x plus 46. Alright, graph it. Alright. And it's a little bit high, so we're going to change our window. My x max, you know, we could leave it like that. Our x min, let's switch this out to negative 1. My y minimum, negative 10, whatever. Let's just put that at negative 1 just so we get a little bit closer. My y max, let's go ahead and make it 50. Maybe we won't go larger than 50, so let's graph it. Oh, it actually does look like we go higher than 50. Okay, so we actually need to increase our window size a little bit more. Let's try 70, I guess. Graph. Alright, so now we can see right here that we do have a good bit at the top. All right, yeah, put it right there. Okay, so we're gonna go back here to graph. We're looking for the maximum height. So the man's here. He looks like he throws the ball up from the roof, and then it comes back down. So he throws it up, and then it comes back down. So we want to see how high he throws it from the top of the roof. What is the maximum height of the ball? So in order to do that, second calc, we're going to find the maximum because it's the top of it. So we're going to hit the maximum, enter. My left boundary, where's my cursor? Cursor's at 3. What's it doing over there? All right, there it is. It's moving. All right, that's a good spot for it. Hit enter, move it to the right. That's a good spot for it. So we want to squeeze those boundaries. Guess it doesn't matter. Hit enter again. So at 1.031251 seconds, the highest the ball goes is 63 feet. So about 1 second, the ball goes about 63 feet. So let's write that down. The height is going to be 63 feet. And we'll just put a little arrow to it. We can kind of see it in our data. 63 feet. That is the largest one. We didn't know that before, but now we do. This data really reflects the graph that we have. All right, let's go ahead and do one more problem. Hang in there. A parabola contains the points -1, 8, 0, 4, and 1, 2. Name another point that is also on the parabola. So I think you guys already know how to do this. Just read the problem, think about how we can find another point. But I'm going to go ahead and do it again on the calculator. We're going to do it together, and you can check it at the end. So actually, I'm going to go ahead and clear my calculator just because I don't like clearing everything out at the end. So I'll do it right now. We're going to go over here to Stat, Edit, and I have my first x value is -1. And then my second x value is 0. I want to hold on to that 0. My third x value is 1. Over here now, I have an 8, I have a 4, and I have a 2. Second, quit, stat, calc, number 5, quadratic regression. Calculate for me, please. And there it is. We have it right here. We're going to pull it down. But how can I use this? Well, I'm going to use it by putting it into y equals. So I have 1x squared, or just x squared, minus 3x plus 4. There's my nice graph. We just want to find another point. We know 3, -1, 0, and 1. Let's just find another point. So let's just go to our table. We can put in any of these. So let me see. Put that in there. And put that in there. I want to hold on to all of that. Actually, I didn't want to hold on to that, but that's fine. I'll just put the table over it. Put the table in there. Beautiful. All right, and I could just pull any of these. So, let's just, I'm looking here at the table. And I see it here. I see another point here, another point here, another point. I don't have any of them, so I could just say 6 and 22. That's at the bottom. Started from the bottom. Now we're here. All right. So it's totally off track now. But that's how you're going to use the calculator to create a quadratic regression model of all the data that you're going to see coming across. Again, if you have any questions, please don't hesitate to reach out and let me know. You have all of my information. My name is Mr. Hernandez, and I'm always here to help.